Imagine a world where the ground beneath your feet rumbles ominously. The sky turns a haunting shade of gray, and ash begins to fall like a relentless, choking snow. This isn't the plot of a science fiction movie, but a potential reality if a supervolcano were to erupt. Today, we're delving into the what-if scenario of a supervolcano eruption. What would happen? How would it affect our planet? And most importantly, how would it impact us? Let's explore this explosive topic. First, let's understand what a supervolcano is. A supervolcano is a volcanic center that has had an eruption of magnitude 8 on the Volcano Explosivity Index, VEI, meaning the volume of deposits for that eruption is greater than 1,000 cubic kilometers. To put that into perspective, that's more than 240 cubic miles of material ejected into the atmosphere. This is enough to bury the entire state of Texas under a layer of ash over 4 feet deep. The term supervolcano implies a superlative scale of eruption that can cause devastation on a global level, far surpassing any eruption we've witnessed in recorded history. Unlike typical volcanoes that form mountains, supervolcanoes create large calderas, which are depressions in the ground formed after the eruption empties the magma chamber and the surface collapses inwards. Throughout Earth's history, there have been several supervolcano eruptions. One of the most famous is the Toba eruption that occurred around 74,000 years ago in present-day Indonesia. This eruption was so massive that it is believed to have caused a volcanic winter, drastically reducing global temperatures by as much as 15 degrees Celsius. The resulting climate shift led to severe reductions in plant and animal populations, and it may have brought early humans to the brink of extinction, creating a genetic bottleneck in human evolution. The ash from this eruption was spread over a vast area, reaching as far as India and the Arabian Sea. Another notable example is the Yellowstone supervolcano, which last erupted about 640,000 years ago. This eruption formed the Yellowstone caldera, a massive volcanic crater, and covered a large portion of North America in volcanic ash. The effects of this eruption were felt as far away as the Gulf of Mexico. The eruption expelled more than 1,000 cubic kilometers of material, blanketing the surrounding areas in thick layers of ash and drastically altering the landscape. The sheer scale of these past eruptions helps us understand the potential consequences of a future supervolcano eruption. Supervolcanoes don't erupt without warning. Scientists monitor them closely for signs of activity, such as increased seismic activity, ground deformation, and changes in gas emissions. For instance, at Yellowstone, scientists have observed ground swelling and frequent earthquakes, which are indicators of magma movement beneath the surface. The Yellowstone Volcano Observatory, YVO, constantly monitors the area using a network of GPS stations, seismometers, and gas sensors. These instruments detect subtle changes in the Earth's crust and help scientists predict potential volcanic activity. However, predicting the exact timing of an eruption remains a significant challenge. Supervolcanoes operate on geological timescales, meaning their activity can span thousands to millions of years. The signals of an impending eruption might appear decades or even centuries before the actual event. Despite these challenges, ongoing research and technological advancements are improving our ability to monitor and understand supervolcanoes, providing valuable data that could one day help mitigate the impacts of such an eruption. If a supervolcano were to erupt today, the immediate effects would be catastrophic. The initial explosion would release a colossal amount of ash, gas, and volcanic material into the atmosphere. This pyroclastic flow, a fast-moving current of hot gas and volcanic matter, would incinerate everything in its path, causing widespread devastation within a radius of hundreds of miles from the eruption site. Buildings, infrastructure, and natural landscapes would be obliterated by the intense heat and force of the eruption. The ash plume from the eruption would rise high into the stratosphere, where it would be carried by wind currents around the globe. This ash would begin to fall back to Earth, covering vast areas in a thick layer. The weight of the ash could collapse roofs, clog machinery, and contaminate water supplies. The air would become filled with fine ash particles, making it difficult to breathe and posing severe health risks to humans and animals. In addition to the ash, the eruption would release massive amounts of sulfur dioxide, SO2, and other gases into the atmosphere. The eruption would have profound effects on the global climate. The vast amount of ash and sulfur dioxide released into the atmosphere would block sunlight, leading to a phenomenon known as volcanic winter. This reduction in sunlight would cause global temperatures to drop significantly, potentially by several degrees Celsius. The cooling effect could last for several years, disrupting weather patterns and shortening growing seasons. Crops would fail, leading to food shortages and famine. The 1815 eruption of Mount Tambora, which caused the Year Without a Summer, serves as a historical example of the climatic impact of volcanic eruptions, albeit on a smaller scale compared to a supervolcano. The sulfur dioxide released during the eruption would combine with water vapor in the atmosphere to form sulfuric acid aerosols. These aerosols would create a reflective layer, further reducing the amount of sunlight reaching the Earth's surface. This would exacerbate the cooling effect and lead to widespread climatic changes. Rain patterns would be altered, leading to droughts in some regions and excessive rainfall in others. The disruption of the climate would have cascading effects on ecosystems, agriculture, and human societies around the world. The health impacts would be severe. Inhaling volcanic ash can cause respiratory problems, including asthma, bronchitis, and other lung diseases. The fine particles can travel vast distances, affecting populations far from the eruption site. In addition to respiratory issues, the ash can cause eye irritation and skin problems. People with pre-existing health conditions, children, and the elderly would be particularly vulnerable to the effects of the ash. The economic impact would be staggering. The immediate destruction of infrastructure, homes, and industries would cost trillions of dollars. The long-term effects, such as disrupted agriculture, health crises, and the need for massive reconstruction efforts, would strain the global economy. Tourism in affected areas would also plummet, adding to the economic woes. The agricultural sector would be particularly hard hit, with crop failures leading to food shortages and increased prices. The disruption of global supply chains would affect industries worldwide, leading to economic instability and potentially triggering a global recession. So, what can we do to prepare for such an event? While it's impossible to prevent a supervolcano eruption, we can mitigate its effects through careful monitoring and planning. Scientists around the world are constantly studying supervolcanoes, using advanced technology to detect early warning signs. Emergency plans, including evacuation strategies and stockpiling essential supplies, can help minimize the loss of life and ensure communities are better prepared to cope with the aftermath. Education and public awareness are crucial components of preparedness. Governments and organizations can conduct regular drills and simulations to ensure that emergency services and the public know how to respond in the event of an eruption. Building resilient infrastructure that can withstand ashfall and implementing land use planning to avoid high-risk areas can also reduce the impact of a supervolcano eruption. International cooperation and data sharing among scientists and governments are essential for monitoring supervolcanoes and coordinating response efforts. Modern technology plays a crucial role in monitoring supervolcanoes. Satellite imagery, ground-based sensors, and computer models help scientists understand volcanic activity and predict potential eruptions. Innovations in early warning systems can provide valuable time for evacuation and other protective measures. For example, satellite-based remote sensing can detect changes in the Earth's surface, such as ground deformation and thermal anomalies that indicate magma movement. Ground-based sensors, including seismometers and gas detectors, provide real-time data on volcanic activity. Additionally, ongoing research into climate engineering, such as dispersing reflective particles in the atmosphere, could potentially mitigate the cooling effects of volcanic winters, though such methods remain highly experimental. Advances in artificial intelligence and machine learning can also enhance our ability to analyze vast amounts of data and improve eruption prediction models. By leveraging technology and scientific research, we can better understand and mitigate the risks associated with supervolcanoes. The psychological impact of a supervolcano eruption would also be significant. The sudden and catastrophic nature of the event, combined with the long-term environmental and societal changes, could lead to widespread anxiety, stress, and trauma. Mental health services would be essential in helping individuals and communities cope with the aftermath and rebuild their lives. While the prospect of a supervolcano eruption is daunting, it's important to remember that such events are extremely rare. The last known supervolcano eruption occurred 26,500 years ago at Lake Taupo in New Zealand. However, the potential consequences are so severe that it warrants our attention and preparedness. By investing in scientific research, early warning systems, and robust disaster response plans, we can better equip ourselves to handle such a catastrophic event. Thank you for joining us on this journey into the world of supervolcanoes. If you found this video informative, please give it a thumbs up, share your thoughts in the comments below, and don't forget to subscribe to our channel for more intriguing what-if scenarios and scientific explorations. Hit the notification bell so you never miss an update. Stay curious and stay prepared.